Optotrak is a recording device to collect the kinematics data, and it includes cameras, system unit, strobe, markers, calibration cubes, and a pointer. In this video, I will explain how to work with FBWM software to successfully record with Optotrak system. To be able to use FBWM software, first of all, we need to create a directory where the data should go. For this, let's double click on this PC icon in the desktop and open Drive D. Let's make a folder and a subfolder. Do not name your folder Pilot, Data, or Test. Instead, you can use your first name or your last name or your project name as your folder name. Remember that you can never use the name of participant as your folder or your subfolder name. For instance, let's call our subfolder subject01. Now we need to copy a file which contains the settings for FBWM software to this directory, so the software can read the settings from there. This file called params.txt, which can be found at desktop. Let's go back to the desktop and copy param.txt file and paste it into subject01 folder. Now is the time to work with FBWM software. Let's go back to the desktop and double click on FBWM software. The following windows pops up. Here we need to select the subject01 folder. By doing this, all the data will be placed in subject01 folder. The fact that we have put the params.txt there means that the software will get its settings from this file. Now is the time to calibrate Optotrak system. First of all, we need to turn the cameras and system unit on. After that, let's click on Optotrak menu and select the first option, which is determine Optotrak configuration. Here we have to wait until a small window pops up. If we use two cameras, the system will show us two serials at the bottom of this small window in front of camera font. But if we forgot to turn the cameras or the system unit on, as you can see here, the system will show us none in front of the camera's font. Now is the time to calibrate Optotrak system. Before starting the Optotrak calibration, we need to make sure that the cubes is connected to the first port of the system unit. After that, let's go to Optotrak menu again and select the second option, which is Calibrate Optotrak Register Align. Then a following blue window with 6 panels pops up. Here we have to wait until the faded panels become unfaded. Optotrak feedback panel at the right side of this blue window shows no error. This means that we can start the Optotrak calibration. For instance, if we forgot to connect the cubes to the first port of the system unit, the Optotrak feedback panel shows an error. This means that we cannot start calibrating the Optotrak system. In the Optotrak real-time display panel, there are 16 green or red markers which represent the number of markers on the cubes. And in the Optotrak collection parameters panel, the collection time is 30 seconds, which represent the time of Optotrak calibration. When we press the Collect Data button, we start a dynamic calibration. For this, we swing and rotate the cubes along the measurement area for 30 seconds. There is no specific way to do this, but make sure that the cubes is registered by all camera. After 30-second dynamic calibration, a following window pops up. Here, we need to select the rigid body file of the cubes. Based on the serial number at the top side of the cubes, we select the rigid body file. For instance, here the rigid body file is CU01165. After selecting the rigid body file, a following small window pops up, which indicates that the Optotrak system successfully registered. Press OK and wait until the black dot goes from register to align. Here we need to define the alignment for the Optotrak system. As you can see in the picture, we define x-axis in mediolateral, y-axis in anterior, posterior, and z-axis in vertical direction. Here, make sure that the cubes is registered by all cameras and then press the Collect Data button. After 3 seconds, a small window pops up, indicating that we successfully aligned the Optotrak system. Press OK. Another small window immediately pops up. Again, press OK. By pressing the Quit button, the Optotrak system is fully calibrated and is ready for the measurement. After Optotrak calibration, all parameter settings should be checked and, if necessary, adjusted. For setting the parameters, let's go to Experiment menu and click on second option, which is Set Parameters. A following yellow window pops up. This window consisting of 3 forms to switch between, namely General, Optotrak, and Analog input. In General form, the application name can be selected as the default. The trial number will normally be set automatically. If our data folder is empty, it reads 1. Collection time is the maximum number of the seconds a single trial takes. During the measurement, it can easily be adjusted just before each trial. In Optotrak form, first of all, enable Optotrak defines whether Optotrak data has to be collected during the measurement. If the green light on the button is off, the Optotrak parameters will not be accessible. And if the green light is on, Optotrak data will be collected and the parameters value can be adjusted. The strobe port table panel defines the number of markers. This should be in line with the number of markers which are attached to the strobe. For instance, if we want to use 3 clusters of 3 markers in our experiment, we need to set 9 markers in this panel. To digitize the bunny landmark, the pointer can be attached to the second port of the system unit. As you can see here, we set 6 in front of port number 2 because we use a pointer with 6 markers on it. The sample rate can be freely chosen, although the number of markers times the sample frequency is limited to 3000 300 Hz with Optotrak 3020. The recommended value for strobe voltage is 7, but depending on the camera setup and the lighting conditions, a slightly higher or lower value may provide a better visibility of the marker. The marker frequency depends on the number of markers and the sample rate, and must be no less than number of markers plus 2 times sample rate. In the above example, with 50 markers and a sample rate of 50 Hz, the marker frequency should be at least 750 Hz. Moreover, the maximum marker frequency in the Optotrak 3020 systems is 3500, but keep it a bit lower than 3500 because it might easily cause problems. The default value for duty cycle is 0.5 and it doesn't need adjustment. Only when we use a higher strobe voltage, it might be better to lower the duty cycle to prevent the markers from burning, especially if long trials are involved. If you want to see a graph of three-dimensional position data after each trial, check the offline feedback. At the top right of the form, we can find the setup called Real-Time 3D option. Enable the Real-Time 3D option is preferred because this provides more control both during the trials and between trials. Real-Time 3D option has two sub-options. If no explicit instructions have been given, they should be set as shown in the form. The first, checked; the second, cleared. Below the real-time feedback section, three additional checkboxes are present. Use interpolation, use external clock, use external trigger. As Optotrak markers are fired sequentially, the default behavior of Optotrak is to time interpolation raw data within a frame. Use interpolation should be checked to activate this behavior. The use external trigger needs to be checked when you want to synchronize the Optotrak recording with another recording device. Finally, in the bottom middle of the form, the camera setup can be entered. The option Stimulate Optotrak System is only for testing purposes and should always be off during measurements. Since we have already calibrated the Optotrak, the camera file refers to the subfolder that was created. If a single camera is used, the Optotrak doesn't have to be calibrated, and the option Use Standard Coordinate System may be checked to use a standard camera file. The third form concerns data from force plate and other analog devices, for example, EMG or acceleration meter. If only Optotrak data needs to be collected, enable FB1, enable FB2, and additional channels should be simply unchecked, and all other settings may be ignored. If data of one or two force plates are desired, enable FB1 and enable FB2 should be checked. And three types of force plates can be chosen: from Kistler for the Kistler platforms which mounted into the floor, movable for the transportable platforms, and dual built for the platforms which mounted into the treadmill. Offline feedback indicates if a graphic representation of forces and points of application should be shown after each trial. At any time, the current settings can be saved to disk by pressing Apply. Pressing Cancel allows for returning to the main screen, ignoring all adjustments after the last apply, whereas pressing OK returns to the main screen with all adjustments saved. After all parameters have been set, we can start measuring. The measurement screen can be found at Experiment menu and the third option, which is Measurement. Here we have to wait until the faded panels become unfaded. If everything goes as planned, a green bar appears at the upper right of the screen in the Optotrak feedback area, and measurements can be started. But if a red bar appears at the upper right, something went wrong with the Optotrak system and the measurements cannot be started. At upper left, some parameters concerning Optotrak are shown, none of which can be changed in this screen. If real-time 3D option is checked, there is a button enabled in the upper middle of the screen to view the Optotrak data in real time. This is specifically useful to check if all markers are working and positioned well. Note that during viewing the real-time data, the markers are activated and thus heat up. If markers are activated too long without a break, especially when using a high voltage, they can burn through. At the bottom left of the screen, some other parameters are shown, which also cannot be changed, like data folder, the current trial number, and some information related to analog data from force plates and other sources. The one parameter that can be adjusted is the collection time, which reflected in the time bar at the bottom middle of the screen. With the Collect Data button, a measurement can be started. If real-time 3D option is enabled, an overview of the visibility of markers will be shown during the measurement. Each marker is represented by a LED. If colored green, the marker is in the field of vision. If colored red, it is not. If a LED stays red unexpectedly, check the corresponding marker after the measurement using Optotrak real-time display located at the top middle of the screen. The marker may be disconnected, dislocated, or even broken. The first screen which pops up after the end of each trial includes the three-dimensional position data. For instance, if 50 markers were sampled, it might look as what you can see here. The left, middle, and right panels indicate the trajectories of the X, Y, and Z coordinates of the markers respectively. The name of file that correspond to a single measurement starts with TN followed by a trial number consisting of 6 digits. After collecting data, all data files are stored in the folder that was selected at the startup of the FBWM software. The data files are grouped by including the trial number in the names. Each file name consists of the letter TN followed by 6 digits. The extension indicates the type of data. A file ending with .ndf contains the three-dimensional position data from Optotrak. Files with the extension AFP or AFP2 contain the raw analog signals from the force plates. If gauge data are available, there will also be files with the ground reaction forces, extensions, GRF and GRF2, and points of application, extensions POA and POA2. Data files with extension GAI contain the data from all the additional analog input channels. Moreover, for each trial, there is also a TXT file containing all parameter values that were in effect during this trial. Last but not least, copy data after measurement, because measurement computers are in use by many users and you don't want to lose your data.